Limited. So we are having three panelists for today's topic of discussion. Actually, today's topic you already know that we'll be talking on earthquake, a decade-long mega disaster event, lessons learned, key engineering challenges, and mitigation. So, as per the program, Professor Chandan Ghosh was the first speaker. So, because of some program, he will be joining. He already joined, but he will be talking at the end of this session, third panelist instead of first panelist. So, in this regard, I think Professor H.B. Kaushik, Hemant B. Kaushik sir can deliver his ideas and share his ideas as a first panelist today. So before going to Professor Kaushik, let me just give a brief intro about Professor Kaushik to the August gathering. Professor Hemant B. Kaushik is a professor in the Department of Civil Engineering and Center for Disaster Management and Research at IIT Guwahati. He is also the Associate Dean of Academic Affairs for online programs at IIT Guwahati. Dr. Kaushik is a structural engineer and his research interests in earthquake-resistant design, non-linear behavior, seismic retrofitting, large-scale testing, vernacular housing typologies, and earthquake damage surveys. He has guided 6 number of PhD scholars till now and has 3 PhD scholars working under him at present. He has published several research papers in national and international journals and conferences on different research areas and has received national and international awards for some of his excellent publications. He is a member of several international national professional societies and institutes and a fellow of the Institute of Engineers, India. He received the Young Engineer Award from the Indian National Academy of Engineering, INAE, in the year of 2010 for his contribution to earthquake and structural engineering, and was selected as INAE Young Associate in 2013. Professor Kaushik is a member of the Earthquake Engineering Sectional Committee, CED 39, Bureau of Indian Standards, which looks into the development of standard codes of standard code of practice for earthquake resistance. So, this is the
speaker. Please make sure your speaker is properly connected.
Is it fine? So, Professor Kaushik, can you hear me?
Yes, Dr. Rajiv Saha, I can hear you. Thank you so much for the nice introduction.
Okay, sir. Okay, sir. You can proceed, sir.
So, can I share my screen?
Sure, sir. You can take over.
Okay. And to save bandwidth, I will stop my video. I hope it is visible.
It is visible, sir. It is visible.
Okay. Okay. So, first of all, let me thank the Institute of Engineers India Tripura State Center for inviting me to interact with the other colleagues and other people who are attending this very interesting workshop. The title of this presentation I have chosen right from the title of the event. So basically, we will discuss what message we can actually use from the learning that we already had from past several earthquakes in risk mitigation for the future. So I will not show you many photographs of the damages during these past earthquakes that we have seen, recent earthquakes, but still to make the story complete, let me show you some of the photographs. So let me start with the 1999 Turkey earthquake, which was on 17 August. The magnitude was 7.6. You may not remember these photographs, but this earthquake was one of the biggest earthquake that happened in Turkey since long. And it resulted into development of many seismic design codes for different types of structures in Turkey. Then along the same lines, in 2001, our Bhuj earthquake opened our eyes as if we were thinking that such big earthquakes cannot happen in India, but then this earthquake resulted in, again, a lot of development in many aspects in the country. Then happened a very large earthquake, one of the biggest earthquakes that humans have experienced so far, that is magnitude 9.3 this earthquake in Sumatra. The earthquake was so big that even some buildings in Port Blair, which is about 1100 kilometers away from the epicenter, they collapsed. Plus, there is huge damage to the infrastructure. Then in 2005, another big earthquake occurred in Kashmir, and we saw what happened to all these unreinforced masonry buildings and even the apartment buildings similar to the Bhuj earthquake. In 2006, there was a very small earthquake in Sikkim of magnitude 5.4, which was followed by this bigger earthquake of 6.9 magnitude in 2011. So we covered both of them, and the structures which we identified as vulnerable in 2006 were all highly damaged during this 2011 earthquake. And in 2015, Nepal, you see there were two earthquakes, but on 25th of April, the 7.8 earthquake, it created havoc to all building typologies, being RC buildings, the unreinforced masonry buildings, even some of the local typologies, heritage structures, all were damaged to a very significant extent. In Imphal, there was an earthquake of magnitude 6.7 in 2016. That resulted into huge damage, even to this very famous women's market in the Imphal city. And this is the church building which got damaged. This was followed by a very small earthquake, not in terms of magnitude, but in terms of effect. This was in Assam, Sonitpur, in 2021. So though the magnitude, local magnitude recorded was 6.4, but the damage was not much. But there was a huge liquefaction in the area. So you can see here the liquefaction that occurred in a large stretch of land near Brahmaputra banks, just on the Brahmaputra banks. But otherwise, the structural damage was very limited during this earthquake. And in 2022, another earthquake occurred in Nepal, which was 6.6, which resulted in huge damage to, again, unreinforced masonry buildings, all sorts of unreinforced masonry buildings. And finally, this 2023 double earthquake that occurred on the border of Turkey and Syria. So the location of this earthquake was different than the location of 1999 Turkey earthquake. But the damage, the death toll, the economic damage was huge. It's comparable to 1999. So the question now people are asking what they have learned during this last 24 years. I'll ask a different question. The question is, which buildings have performed better during these earthquakes? We have seen hundreds and thousands of these photographs of building collapses, of huge damage to different infrastructure. But are there any buildings which have performed good? So in Turkey, for example, there are many vernacular housing systems. Out of them, particularly these two systems perform better in comparison to the reinforced concrete buildings and unreinforced masonry buildings. So these are the Hemis construction, both of them. And you can see what is the difference here. These are unreinforced masonry buildings otherwise, but they have large number of this timber as vertical, horizontal elements, as well as the bracings, the diagonal elements. So in between these timber elements, the wooden elements, they fill the masonry, different types of masonry. So it has been found that these buildings, they performed better compared to the other buildings. So the damage was limited. The other type is Baghdadi. So this is a Baghdadi building. Again, you can see here that these are all wooden elements. In between the wooden elements, they fill different sorts of material. Now coming to India, we have two systems which have performed better. One is Dhajji Diwari, which has performed really well during past many earthquakes. So this is a Dhajji Diwari system. And you can actually draw parallels between this system here in Kashmir and the Hemis construction system in Turkey. So basically what people have done, they have actually reduced the free length of these masonry walls. They have incorporated many additional elements inside the wall so that these walls, they stay there, they remain there in the original position during the earthquakes. The other system is a Taj system. And this is a very unengineered, non-engineered type of structure where when people see that any crack is there, when people see that some damage is occurring to the wall, they insert one wooden log anywhere. So there's no uniformity here. Wherever they feel that some additional wood is required, they simply insert it. So these have also performed better than the unreinforced masonry buildings. But still, there is a documented evidence that these buildings also have suffered some damage. Here you can see the comparative damage to this building, the Himes building, versus reinforced concrete building. Assam type housing, which is found across the Northeast, is the only building type which has not seen any collapses in their history. So there is no documented evidence where anybody has seen that because of the direct effect of earthquake shaking, these buildings have collapsed. Though there are some damage, which I'll discuss later, what type of damages these buildings can suffer. These are very minimum, negligible damage that these buildings suffer because of the direct effect. When I say direct effect of earthquake shaking, I mean there are some damages, collapses reported because of landslides, right? Because of flooding, but not because of the earthquake shaking. And you can find single-story, multi-story buildings, large number of such buildings in the entire Northeast. So these are the only buildings that have not seen any of the collapses. Now, then which building types are most common? Looking at the several photographs those are showing how different buildings have performed during different earthquakes. What we see is masonry is the common construction materials in all these buildings, which you have seen performance in the past earthquakes. In India, we have majority of the building stock constructed using URM. And there are many reasons for that, because they are easily available, they're economical, and there are many reasons. So you find any city in India developed, underdeveloping, whatever, we find masonry there. So what I did here in today's presentation, I will consider 4 building types based on the use of masonry, and then I'll try to see how these buildings behave during earthquakes, during lateral loads, and then we'll try to compare this building. Now, if I just show you one photograph, one figure, so this is a seismic zone map of India. Superimposed on this seismic zone map are 2 things, basically the circles. So what I'm trying to show here is the population density versus the density of the unreinforced masonry buildings. So these circles, the color of these circles, they indicate population. So here it is. So red color means large population, and so on and so forth. So the size of the circle indicates the density of the URM. So bigger the circle means bigger is the density of the URM. So now the problem is the places of high population density also are the places of high URM density. So that brings into picture a very high seismic risk in that region, which we have to think about. So the first building type that I considered is, of course, the masonry infilled RC frame buildings, which all of us love a lot. Second is the unreinforced masonry buildings, which all of us have simply forgotten, in the sense that the good construction practice has been forgotten, but of course we are constructing these buildings. The third type of building is the confined masonry buildings, which are very popular in some of the countries where the earthquakes are very common. For example, Chile and some of the European countries, some of the Latin American countries. And these buildings have performed really well during these earthquakes. But I have not shown these buildings as better performing buildings in Turkey and some Indian earthquakes because they are not commonly constructed there. And finally, the fourth type is the traditional vernacular building, particularly Assam type or the Ikra houses that we will consider. So here also the masonry is used below the cell level. So only this part is masonry. Though there are some other systems, the Diwari and Tak, but compared to Ikra type houses or Assam type houses, these buildings have not performed that well, though they performed better. So we'll just consider one building, traditional building, which is building type, which is Assam type house. So what I will do, we have done large scale testing of many building typologies, all these 4 and then some others, but I'll show results for 4. So I will show you some test results, not in terms of numbers and mathematics, but in terms of how they perform, some of the videos. And then we will compare how the strength is, how the lateral drift is, how the lateral strength is compared to the other building systems. So starting with reinforced concrete frames, we tested large number of frames, out of which I'm showing you results of 3 frames here, in which the first frame did not have any masonry infill, so we call it bare frame. The second frame had full infill masonry wall, which is called infill frame, and the third frame had 10% opening in the wall. So this is how we tested this wall. Basically, slow cyclic testing loads were applied at the slab level of this frame, and a lot of sensors were used to record the performance. Let us see this video, how this frame, single frame with full infill, it performed. So the loading is applied here, and the loading was applied very slowly, so that it takes roughly 2.5 hours to complete the single test. But I will be showing you the video in very fast forward manner in about 30 seconds. If you can read this number, it shows how much displacement is applied at the top here. So you can see the cyclic loads are applied. Basically, we are applying the displacements. And here we have applied so far 20 mm displacement at the top. So 20 means 20 positive and 20 negative. So this side as well as this side. And you can see here immediately within 20 mm, 30 mm, you have huge cracks in the walls. There are some cracks in the columns, beams, right? So at 40, 50 mm displacement, you will find that these columns will actually damage so much that all the concrete will go away. And now the wall you will also see that wall is also collapsing in the out of plane direction. The entire concrete has fallen off from here. So this has all the bars have yielded. And finally, what you get is, of course, we have supported this frame in the out of plane direction so that it is not collapsed. There's no accident. So what we finally got is this kind of response. So this is the bare frame. So on the y-axis, you have the lateral load that the frame resisted in both plus and minus directions, push and pull. And the x-axis is the displacement divided by height of the frame, which is the drift. So in terms of percentage. So this is the cyclic response and also the envelope of the cyclic response. Now you compare this with the infill frame, obviously you will get very high stiffness and you will get very high strength. But the ultimate displacement at which it fails is actually reduced drastically. So it is failing, let's say, at around 4% drift. But in case of bare frame, even at more than 5% drift, the strength was not reduced significantly. There's a significant opening of influence of opening, of course, the strength reduced compared to the fully infill, and also the failure occurred early. So remember these results, we'll come back to these results when we compare all these 4 building types. So the next type is the unreinforced masonry buildings. So again, we consider first the 3 walls only. These are not buildings, but only 3 walls. First is full, there's no opening. Second wall is basically with a door opening, and third is a window opening. Now you'll find this video very interesting, and let me see if you can find any damage in this wall. So the same setup is there. We are applying the displacement at the top, and the displacement is shown here. It is expected that the cracks will start emanating from this region or this region and at the bottom, because this is the region of high stress concentrations near the opening. So we have reached about 4 mm. So far, there is no crack. But if you remember RC frame infill, there were cracks even at 4-5 mm. But here you can't see any of these things. But then immediately there is a failure. And I'll show you why I'm calling this failure. You cannot see actually anything, any damage or any deformation of the wall. That is because it simply failed at around 8 mm displacement, which is so less to observe. Particularly in a small video, you cannot observe it. More interestingly, there is no ductility here. it immediately failed. So it was a very brittle failure, immediate failure. So here we are showing this wall. So it failed at around less than 6%, less than 6 mm displacement. We're not talking about drift here. And this is a full scale wall, 3-meter length, 3-meter height. So then what we did, we tested the entire building. So it's a full scale building and it had 4 walls. 2 walls were having window openings. 1 wall, this front wall, has a door opening. So let us see how this building performed. The same test setup was used. The displacements were applied cyclically at the slab level. And this video shows that we have applied 19 mm displacement so far. And you can see the rocking behavior that is occurring in this wall. So rocking means this part of the wall is actually dancing over this bottom part. And that is because the continuous crack that has happened along the whole length of the building at this level, starting from the opening here. So that is what I was mentioning. Because this is an area of high stress concentration, we generally expect the cracks here. Also, you will find some cracks here at the bottom. That is also very common. So when you compare a single wall with the entire building, at least you can see some of the displacements. So people will get some time, but not as much as we find in case of RC frame. So the third building typology is the confined masonry. So I'll just spend 2 minutes to explain what is confined masonry to those audiences who have not heard about it. So here is the RC building with infill. So what we do here, we construct the frame first, RC columns and beams and slabs. And then we fill these open spaces in the frame with masonry infill. So when we do that, we don't expect that these masonry walls will resist the vertical gravity load that is coming on the slab, because these beams and columns are designed for that purpose. Also, we don't expect that these walls will resist any of the other loads. We don't design them for that purpose. On the other hand, when we construct the confined masonry walls, we first construct the walls. The dimensions of these columns are so less that we call them tie columns. The dimensions of the beams also are very less, so we call them tie beams. And then we cast the columns and the beams along with the slab, or maybe we can go on casting the columns along with the wall. As the wall height is increasing, we continue casting the columns. Finally, these walls are designed to resist the gravity loads as well as all other possible loads. So that is the primary difference between this reinforced concrete and confined masonry. Structurally, RC buildings are much superior to confined masonry. But then what happens? Most of the people, particularly in semi-urban and rural areas, they don't hire engineers. So the reinforced concrete buildings constructed in those areas are not safe because the codal guidelines are not adhered to. Therefore, this concept has come into picture. And this is not story of only India. In many other countries, similar things happen. So this concept is now very famous. So here what we do, we don't design these columns, tie columns and tie beams to behave in a ductile manner. They are simple small elements, but the walls, the brick should be of good quality. So this is a primary difference. So there's no concept of the equivalent diagonal strut in case of confined masonry building. Though some strut development may be possible depending on the relative strength and stiffness of the tie column and the beam and the wall, but primarily the way these confined masonry buildings resist the load is different. So let us see what type of tests we did. Now, since it is primarily a masonry typology, the aspect ratio plays a very big role in how these buildings will perform. So we carried out tests considering 3 aspect ratios. So one is a very slender wall, then an intermediate wall, and the third wall was a squat wall. So basically a square wall. So I'm showing you results for one specimen for aspect ratio 2. So now here you can see lateral drift 0.75, 1% lateral drift we have already applied. So looking at this, you can see that the performance-wise, it appears to be quite similar to masonry infilled RC frames. But when I say similar, that is a very big statement because these columns are not designed to behave in a ductile manner. Still, I'm saying similar. So that carries a very large weightage. Now let us see how these frames perform. So these are scale frames, not the full scale. So these are 3 frames. You can see that when the frame aspect ratio is reduced, so the damage scenario also changes completely. And that is why we tested 3 frames. And here you can find the load deformation curves or the load lateral drift curves, different curves altogether. So although for the squat wall, you have high strength compared to the other 2 walls, but its failure is also brittle. It fails quickly. Finally, the Assam type wooden housing. So we first tested some frames of these buildings. So first frame is without any infill. Now this infill is very interesting. In case of Assam type wooden housing, this infill, which is shown in this figure here, is made of bamboo strips. So they cut the bamboo strips and then the mesh of these bamboo strips is inserted inside this wooden frame. There's no other connection. There are some grooves here in this wooden element, and there are some holes here in these vertical wooden elements. So these horizontal strips are inserted in the holes, and the vertical strips of these ICRA walls are simply inserted into the grooves here. That is the only connection. And then there is a plaster on both the faces of this wall. So just to see if there is any influence of these ICRA walls, this infill on the overall performance of the wooden frame, we tested these 2 frames. Then we inserted one window opening and again a door opening. Similar testing was carried out. And let me show you this video again. What I want you to please concentrate on this connection here. The vertical alignment between these 2 members, you can see what happens to that alignment when I apply the lateral displacement here. Plus, remember, this is a normal masonry infill wall, and these are the bamboo strips ICRA. So just compare these two walls, then you see the video. So we have already reached about 20 mm, right? And this 20 mm displacement, you can find our masonry infill wall has cracked, which is expected. But there is no other crack, there is no other damage to the entire frame. Though there are some separation here at different locations, you can find some separation, but that is fine. So there is some small crack here because of large separation. Look at the displacement. We have almost reached about 140, 150 mm, which is huge. Again, this is a full scale frame, height is 3 meters. And now you can see the ICRA wall, how does it look like? So these are the bamboo strips. Look at the vertical alignment of this connection, which I mentioned. There is no alignment. So the connection is broken because the connection was so weak, it was so flexible, using only nails, that connection was made. So the point I'm making is these buildings are really flexible. They allow displacements, and you see up to what drift level we have actually gone. So we have seen this building, this frame. So it loses some strength because of the cracking, because of the failure in the nails, but then the load is again redistributed to the other members. So again, some strength reduction is there, but then it increases again. And this happens all the time, up to 8.5% lateral drift. We couldn't test it after that because that is our limitation in the testing, but it was behaving very nicely up to that. Compared to this frame, which had no ICRA walls, you can compare that the huge influence of these ICRA walls on the frame behavior. And then the influence of openings was also studied. So this behavior of this frame with window opening was quite better compared to even this without any opening. And the reason was even presence of these small steel members here, they enhance the performance. But when you provide a door, the behavior suddenly changes, and we found that because of poor connection between this door panel and the foundation, the failure took very early. Then what we did, we tested the entire building on a shake table so that we understand how these buildings behave so beautifully without any damage during earthquakes. So the result I'm showing you is for the Taft ground motion, which was scaled up so that the peak ground acceleration was 1g. Now, 1g is very high peak ground acceleration. So let's see if you can identify any damage, if you can see any damage to this house. It's a full scale house. It was instrumented at various levels. So accelerometers were placed. At this side, there were LVDTs. Strain gauges were placed at the foundations. And at least I don't see any damage to this building from here, from the video. And as I said, this was a very big earthquake. 1g was the peak ground acceleration. So what we did, we tested the same building with different ground motions, with different intensities of different ground motions. So in total, we applied about 112 ground motions, but there was no significant damage. Significant, I'll not use the word significant. Even the damage was so negligible that we couldn't damage that building at all. So finally, what we did, we shifted the same house specimen and we applied slow cyclic loading like we did testing for the individual frames. And then you'll be able to see some damage to this building. So the displacement that we are applying at the top cyclically is shown here. So this has reached 20 mm, no crack, nothing at all, anywhere. Like the frame, single frame, these are the masonry walls, these are the ICRA walls. So we have reached about 60 mm and no damage, but now at 70 mm, you can find some separation here, some slight damage to these timber elements here. So at 90 mm displacement, again, some minor cracks are occurring, started appearing in the masonry wall and the separation of these different members. But the important point here is, though there is a separation here, I can see this joint here. After the separation, during the reverse cycle, the connection is again joint. So this is happening continuously. And remember here, we are not using any external members to support the house in the out of plane direction. It is supporting by itself. So it's stable. And look at the displacement. This has reached 215, 220 mm on one side. You can see the wall, you can see the openings, you can see how these bamboo strips are used, but you cannot see the failure. Then what we did, we removed this house and we changed the setup such that we simply kept on pushing this house in one direction for about 500 mm. Then this house actually got damaged. Now you can imagine this height is 3 meters, 3000 mm, and we have to apply 500 mm displacement at the top to fail it. This is a huge displacement. Finally, let me show you the normalized responses of all these frames. Now here I'm not using the responses of the buildings, but simply the two-dimensional frames that we tested so that we have a better comparison. And what I did, I'm dividing the lateral load, so the lateral capacity of these frames by the self-weight, so that some base shear ratio can be compared among different housing typologies. Otherwise, it's difficult to compare different frames. So that is why I'm calling it the normalized response. And all these frames that we just discussed, I'll compare here. So on the x-axis, these are the drift in percentage. So drift, like I said, it is the displacement at the top divided by the height of the frame. So I hope you can see this response. This response is basically the response of URM, solid wall, and reinforced masonry wall. Right? It is not even reached one value. Now, one value means the lateral load carrying capacity is equal to the self weight of the building. It has not reached that. It is actually 0.5. so low? That is because its self-weight is very high and it is very brittle in nature. And the drift also is very low. Now let us compare with the other. So the URM with door is even less. And the URM with window, the slight increase in the lateral drift because of the reason I already mentioned, but more or less all these URM buildings, they are lying in this small zone here. Okay, let us compare these with the confined masonry. So this confined masonry, the black color is for the aspect ratio 2.0, right? So now you can see that the base shear ratio is more than 1. So it's about 1.2, which is quite high. But more importantly, the drift it has reached is about 3.5%, after which the load started dropping. Now, compared to this is about 10 times more. The unreinforced masonry is 10 times less. The aspect ratio 1.5, obviously the strength is more or less same, but then the reduction in the strength started occurring quite early compared to aspect ratio 2. Aspect ratio 1.0, we have seen that it failed quite early because of high stiffness of that frame. So you can see the change in stiffness, but the strength is more or less uniform. It failed quite early. Compared to unreinforced masonry, any of these frames is much better. They're performing much better, significantly better, because the strength is twice as high as the unreinforced masonry, and more importantly, the ductility, the deformability is several times higher. And this is what we need during earthquake shaking. And that is the reason why some of these Latin American countries and European countries, they have used confined masonry to a large extent in their own countries. Anyway, let us compare other building typologies. So this is the Assam type housing, bare frame. Now you can see where it is going. When I insert the infill walls, so of course, the weight of the frame increases. And that is how, because of increase in the self weight, though the lateral load carrying capacity was more compared to the bare frame, but this ratio reduces. It doesn't matter, ultimately it reached up to that level. But look at the drift, look at the ductility. It is even double than the confined masonry. And this is a third frame with the window opening and with the door opening. So comparatively, this is the particular reason why these Assam type houses, they don't collapse during the earthquake. Because you cannot see the reduction in the strength here, even at the lateral drift of 6, 7, 8, 9%. We don't expect this high lateral drift during earthquakes, right? But even the strength, if I show you, you have already seen that if I don't divide by the self weight, the strength is quite good. But their self weight is so low, the lateral load is also low, so that it reaches more than 1, the base shear ratio. Finally, the reinforced concrete frames. So this is the bare frame. So you can see here, and remember, this is a ductile bare frame designed in a laboratory, constructed in a laboratory. So this is the best frame you can expect. Our frames constructed on site are much weaker. They are much worse. And look at where the masonry infilled RC frame is compared to all other building systems. There's huge stiffness, and that is the reason we find immediate failure of these infill walls. As soon as, because of the high stiffness, it actually attracts a lot of loads during the earthquakes. But anyway, because we are normalizing the response, it appears to be quite good. And this is the RC frame, 10% opening. So these are all the frames that we have studied. And if I ask you which one is the best, it's a very difficult question to answer. But if I ask you which one is the worst, it's the simplest thing that you can answer, that these 3 frames, the unreinforced masonry, they are not behaving up to the mark. But unfortunately, our majority of the structures are here. We are constructing these, right? So the idea is to at least convert these to these, the confined masonry, or to this vernacular traditional housing. So that is all from my side. So finally, if I can say that the risk mitigation strategies for future, basically there are no surprises. What we have to do is to improve the construction practice. We have to use the construction materials wisely and follow the design codes. Now, out of the 4 typologies, which one should we adopt? Well, we can adopt any as long as we are using the design codes properly, we are using good materials, the workmanship is good, then we can adopt any of these. But then the unreinforced masonry, they are not recommended to be used in high seismic regions. We have to use the reinforced masonry. And using reinforced masonry is difficult. So there's a concept of this confined masonry, which we can use. Obviously, the masonry can save the structure if used properly, but it can severely damage the structure if not used properly. So this is one point that I would like to highlight. And the second point is, it is actually time to embrace our traditional and vernacular housing systems, at least in those areas where we can do this. It's not necessary to replace all reinforced concrete buildings in a city with Assam type housing. But then at least some of these houses where engineers are not available, where individual houses are being constructed, there's no reason to shift from traditional housing to this so-called modern reinforced concrete buildings. Finally, let me thank the people, my students who actually did all this work. I was fortunate to have Dr. Syed Humayun Pasha, Dr. Tainsamam Chaudhary, Dr. Biswajit Chand, and Dr. Bunisha Bora, who did all this study. I'm just showing the results to you. So thank you all. And of course, let me thank DST for providing the financial support for carrying out this study. So thank you everyone for the patient listening. And if you have any questions, I can try to address.
Yeah, Professor Kaushik, yeah, it's a indeed is a very good presentation from your side with a lot of illustrations, and we can able to see a state-of-the-art experiments you have done in IIT Guwahati. I think audiences really benefited from this kind of lecture from your side. Now, obviously, few queries are there with us in question answer. So we want to take up the queries at the end of the, I think, during the discussion session. So, right, thank you once again, sir, for your kind patience for delivering such lectures out of your busy schedule. You have given time. We are very grateful to you, sir.
Thank you.
Now, quickly, I'm going. There is a development. Our Professor Chandan Ghosh sir has settled down in his home. He has reached, and just we are shifting the program. Now we go to Professor Chandan Ghosh sir directly. Sir, over to you.
Yeah. Okay. Thank you, Dr. Rajiv, for taking up this Saturday evening program, and also Institute of Engineers in Agartala that has taken this step, and also for giving us this message well in advance, more than 2 weeks in advance. So that way, so we could prepare, I could prepare that. And more so, I can see almost 100 or 90 plus participants are there. And this is how with Agartala and Institute of Engineers Association, and I am involved more than 30 years in various way, interacting with all the enthusiast engineers, especially, and also government officials. So now with the set of this online, I think I'm thankful to have such kind of occasion, especially Professor Kaushik is here, and also Manish ji is here. So I am going to present, and last presentation by Professor Kaushik is giving a very, very meticulous description about the vernacular structure that which they have tested, and really marvelous way that how they are performing better. Now, let me take something on such area that let me put my slides quickly. Yeah. Is the slide visible?
Yes, sir. Absolutely fine.
Okay. So the first thing is the photograph taken there, a person, maybe a government official or someone looking at the structure, that how it has failed, and then finding out the reason behind that. That earthquake can make such kind of impact onto our buildings where we have invested a lot. So keeping this thing in mind, what I tried to frame that engineering of disaster risk reduction for urban living in earthquake prone area, especially Tripura, Agartala. It is not east, it is in earthquake prone area. And earthquakes are happening, will happen, and we cannot stop that. Being from engineering fraternity, we have to keep evolving technology, codal provisions, and guidelines, and all these things that are available, that to enforce them, to put them in our building. That is how we look at. So what I would see that by looking at the building after things has occurred, Sonitpur earthquake last year, that has caused building, but not much damage is there. But still, being an engineer and how far we are from the actual performance of the building uh, under the conditions of an earthquake of 6.7, and how this building has failed. So there is a gap between just we are as a seeing the photograph that, oh, it has failed like that. So there is a connection to be set in between that, like in the last lecture, the performance, really, which one is doing better, and doing the laboratory test and also field performance. So here there is a gap that whatever is happening in the field, it has no relevance with the kind of design that we make under the codal provisions that which have been evolved. Even now also the revisions are going on. And at the same time, it is not always feasible to go for, this prototype buildings of 6-story, 7-story, 10-story buildings. It is not feasible also. But I'll show some of those performance of 6-story building or 7-story building, especially soft-story buildings or a typical building of 6-story, that what happens inside the structure and how building cracks. So to take it further, let me look at that. That ultimately, what is DRR is that disaster risk reduction is that, the kind of role or the kind of impact that being caused over there. We are not there to link our research and to link our findings, to link our formula that based on which donation that we make. When structure fails like this, or when situation of the people, especially the elders, are inside and youngsters are like this, then probably we have to ask ourselves, being a professional engineer or in the format, that are we doing some kind of justice to our study and research, or should we put on the blame, as we know that buildings are not being monitored well by the municipal authority or agency. So we have no responsibility over here, seeing the reverse role being created or reverse role being seen over here. It is the sin of Sichuan earthquake in 2008 that more than 70,000 people died. Almost 18,000 are the children. So from this ethical aspect and as well as our professional aspect, the word DRR, disaster risk reduction. In fact, yesterday and today, there are national platform for disaster risk reduction, where Honorable Prime Minister was there yesterday and Home Minister also. So today, today's session is over. around 5:45 at Vigyan Bhavan in Delhi. So this and representation from Tripura and all the states, in fact, were there. And there are a lot of discussions have taken place and emphasized on the science and technology, role of technology, role of surveillance, response team that already formed. So it is not that only from the structural side, we are looking at one particular aspect, that structural behavior of the building, and checking that whether our design, as per our design, performance is safe or not. But here, when life is involved, performance is also involved. And then it comes again onus on us that how we look it forward from that. And so what is happening is that okay, just a minute. Okay. So when we see such kind of crack, again, there is no formula, there is no software. Then to bring that a building which is broken in this manner, it is not possible to correlate with any formula or computer simulation that it is going to crack like this. But there are designs and there are constructions being done which exactly perform the way that it is designed, the way that it is being constructed. So that kind of performance study tests are also being done. So this is in Guwahati after Sanitpur earthquake. You will not find any building, in fact, without any crack in Japan, because it is a most earthquake-prone area. But while seeing the cracks in this manner, we do not have any mathematics to define that this is how cracks is going to come. This is how displacement curve is going to happen. So it is quite impossible, because the kind of bars and members and the kind of connections, the filler wall and the entire beam column junctions and the kind of reinforcements are there. We can simply say that we have no control on that. We have given them in the design, but if it is not placed, see the geometry of that, see the quality of this, the kind of cracks that which is being seen over here. So if we try to justify that this is how cracks has happened and this should be the nature of the crack, of course, there are certain kind of experience and judgment is there while visiting this, whether it is structural cracks or whether it is a non-structural cracks, whether it is repairable, non-repairable. So there are some quantifications are being made and available based on the post, damage or post earthquake or such kind of damage investigation. So now let me go with impact of earthquake on heritage building. In fact, we know more than 7-8 years back, Ujjayanta Palace, which was damaged in 1897 earthquake, it was made again in 1901, and then it was retrofitted 7-8 years back with the central government and state government association. And now we say that it is being retrofitted, and many other such heritage building has been taken, especially in Agartala or Tripura, and then to retrofit it so that in future earthquake, if anything is there, heritage structure can be saved, which are more than 100 years. But there are many cases, especially Nepal earthquake or even like Sichuan earthquake in China, that these are the monuments there. This is the condition of the things. Again, we cannot fit any mathematics or probability or any stochastic modeling to see that if earthquake happens, that we cannot reproduce these things except some animated video or something. So we cannot justify, because these are massive structures. So earthquake is there, they are not quite strong enough to take this, so they have to fail. But do we want such kind of building, such kind of monuments to fail? I think we know that we give more value to from our own residential area, rather we give more value to our temples or temple-like structure or such kind of monuments or heritage structure. But we cannot help. But now sensitization has come, and Tripura has taken a good effort here in making few buildings retrofitted. So, and the kind of, Northeast area, we are not particular to Tripura only, but Institute of Engineers, and through this sensitization program, we can see these are the kind of habitations that in Aizawl or any of the hill city that are living over here. And if we try to put some judgment over this, what to do, and if they are city or municipal authority ask any one of us who are in this area, that please have some kind of justification that whether my building is safe or this cluster of building are safe or not. And if that is the kind of project given, even multi-million-dollar project is given to all IIT or all experts in the country, or even all global experts available in the country, I can bet that no one of us in the fraternity would be able to justify checking few cluster of buildings over here and this is safe. And there is no such medicine, no such retrofitting tools that can be devised, because their cascading effects and other things will be very, very dangerous. And as we are not able to fit any mathematical equation from before to after in this way, no simulation of stochastic or things are possible. Same will be the case of such kind of buildings in Zone 5 area. That this is, of course, that we cannot do much about this thing except taking care of, because these are steep hills. So just saying that in a national seminar like this, nothing can be done is also not the way to deal with, because so much of investment and public and interest, and they are living over there. So in order to safeguard such kind of facilities, I think our research pursuits as well as experiments and justification, judgment, with the huge amount of funding that being allocated to each of the state, including Tripura, from the National Disaster Response Fund, to retrofit few cluster of building, even in Agartala, or even in the Northeast state, or even entire country, including Delhi, that I think our professional say judgment as well as the kind of tools and technique that we do or that available even globally, there is no answer to that. But we cannot sit idle. So that is why we have to check at least what is the vulnerability of these things, especially they are all individually, each of the building, they are made with RCC and following code and other things. But when it is made in this manner, one above the others and other way, the cascading effect will be really unpredictable, and it cannot be simulated in any computer. But of course, there are some digital modeling or animation can be done to see that if this building fails over here, it will come down which way, other way, and there can be some kind of effect can be created to create sensation among them. But what about the people that who are living over there and they want solution, money is there, then we have to come up and to not to in the attitude of helping them, it is rather involving our ethical wisdom and technical wisdom to work together and frame policy and take up the matter in a highest priority, where funding is not a problem. But at the same time, we can say that nothing can be done is not the answer. Something has to be done. So that is what it is. There are many, many millions of such kind of failures are there who thought that all other buildings are better, this has failed. So, and this is not livable. This is not, again, it cannot be reinstated to the condition that before it is. Some of this, like Leaning Tower Pisa, it was leaning more than its stable thing. So it has been, international contract was given more than 2 decades ago. So it has been got back to certain position that with lots of effort, international effort, bought it. But here there is hardly, of course, I don't have that recent document about this, whether they have to demolish it or reinstate it. It is in fact not possible for such kind of building. So think of 10-story building only here, having enough space, got tilted, not livable, and then reinstatement is not possible. So it is to be break open, and then entire loss is there. So we have to take up such kind of practical issues that comes up after an earthquake also. And of course, before even 2 decades ago, we never recognized that here these are, we as and when we learn, because today's topic is what is the learning things that we have from the Turkey earthquake last month. That what is the learning? One thing is, when temples are made in this way, we are now sure both experimental as well as even codal provisions are also there, but performance wise also such kind of structure, which is the weakest point. The weakest point is here. But temples are thousands of years old. They have, we can say they have either survived because earthquake waves that they have experienced, they are not matching with their own natural frequency. That is very easy and simplest way to give a flowery comments. But at the same time, what we have to be particular that for this kind of temple-like buildings where this part is heavier, this part is heavier, weakest link is these things, and how they perform. And in fact, after earthquake of Bhuj, even 400 years, 500 years old, such thing have gone to the ground. So, and so in that case, again, no mathematical equations or performance study can be done, except that I'll show you some of the experiments that are being done on such kind of soft story or weak story failure. And that to say that whether it is monument, whether it is temple, whether it is a building, whether it is a multi-story building with a soft story at the ground or any part in the middle, they will fail, and they are bound to fail for an earthquake that which is very much, 6, 7 or whatever it is in the entire area, that northeast, or even if it is coming from the neighboring country like Burma or other places, that we cannot simply think of that as per Indian standard code. The entire northeast area is under zone 5, and we are unconcerned about what is happening in that Burma and border area, the India, Burma, and that border area. Whatever is happening within 300 kilometer or 400 kilometer, they are going to affect based on our experience. Even sometimes waves go beyond 400 kilometer also, like Mexican earthquake. So taking this forward, and still we go on making such kind of construction, and we think that we are doing a RCC construction which is robust enough, followed the code, and all people, they do in this manner. And recently there are some variation, there are some modifications in the code because this is more easier than doing such kind of implementation measures. This is easier for the contractor or field engineers or even whoever is constructing the building. This is easier. So code has been modified because this is easier. That is not the way. Since 1962, when code has been recommending that there should be some kind of stirrup, red colored stirrup in between beam and column junction. And since it is becoming difficult, so adopting or reframing the code in this manner is not going to justify our professional credence. And this is a very dangerous say moderation that we are looking at the imperil conditions of the earthquake. And the kind of construction in a typical, multi-story building, 10-story, 20-story building, see the beam column junctions that which is being done over here. And in many of such construction, if you calculate the amount of steel reinforcement being provided, we often give a judgment that let us put extra steel, highest quality of steel. But when steel are good enough, sometimes more than 2 times, 3 times in many of the constructions, but putting them in this order, not following this, and putting them in this order or in this manner is not going to make a earthquake resistant construction. And this is being repeatedly taught and repeatedly told, as well as being exemplified in various capacity and training, capacity building programs across the country, not only for the mission, but for the engineers also. So this is one point that I wanted to highlight. And there are certain publications available, soft ground story, and it is very clear that in that, how soft story, ground story fail over here. And these are all being shown. And for engineers like us, we are not unknown about this kind of things. But and also we still go on making such kind of construction ground story with for our this. But we say that right now, let us, whatever, the thousands and thousands of such buildings have been constructed in this manner only, who are bound to fail. I'll show you plain frame building, 6-story building, how they are failing while it is being tested in a robust experimental system, shake table system. But now the technology has come up that when we cannot remove, when even too much of expenditure we cannot afford to, then how to frame or how to place some, at least a wall, masonry wall, or some kind of bracing, or cut the column systematically over here, put some vibration absorber. In fact, IIT Guwahati has evolved, where Hemant Kaushik and the group all have been involved in making a base isolation devices, but it is some prototype structures are also there. But now directly cutting the column with some system and then putting those devices inside can reduce. But for that, we have to check that whether ground condition is or foundation has been good enough or not. In majority of the cases, if we go to the foundation conditions, either they are over design, we should not say that a foundation is being designed, but the kind of assumptions taken over there in the name of factor of safety or factor of ignorance, and there will be much variations in the location as well as performance of the isolated foundation put over here. And so their performance before putting this kind of isolator over here at each and every column or selected area, which are being tested, which are being checked, and which can be verified also through computer simulation. But uniformity in the foundation during earthquake is very important, and which again cannot be easily simulated or checked. So this is one aspect. And this is, of course, taken from those BMTPC guideline, that 24 pages, 24 such things Professor C.V.R. Murthy have developed and his team, that which one will perform better, this one, or this one. So this is what is being constructed. Now, but we know that these are the, because of soft story, these are the buildings which are very highly, exemplified or most well-known photographs, that where cars is sometimes costing more than the cost of the flat. They are being flattened by such kind of failure in earthquake-prone area. So cars are crashed like this due to soft story failure. We have all these things. And this is in Guwahati or even in the NCR area, Delhi area also. We still continue to make such kind of construction, 10-story, 20-story, 25-story, something like that. And we still have that example that in 2001 Bhuj earthquake, even 4-story building, 1-story gone. But at the same time, and how they fail, and we go for failure study also. So that becomes okay, after earthquake occurs and building has failed, then we go for that, where how it has failed. We take various photographs, being a report, but there is hardly any method to survive or to make some arrangement for such kind of buildings that were already this kind of weakness are already there. So, and how it is to be cope up or it is to be taken up. I'll show some example on that. This is just a screenshot. Buildings on stilt liable to fail by earthquake. And 6-story frame building, you see that just I have taken the screenshot over here. This entire video, I think, let me show it from here. That in few seconds of time, how this kind of frame building without filler wall, it is failing. And it is, let us not take it just like that an experiment has been done, and experiment has been done and we just give okay, well, it is failed. See that in few seconds of time, even without filler wall, without filling and everything, in few seconds of time, a 6-story plain frame building is tested and given a shake at the ground. Well, foundation is taken as a rigid one because this one is connected to the bottom plate of the shake table. This is a large scale prototype building, and when it is shaken, then you see that failure. So I have shown there as one of the screenshot where all measurements, this is the reaction frames and everything is there, and you can see the so I would so now you can see that okay, what happened? Oh, stop the presentation. Yeah, let me share it again. Okay. Oh. I think, where is that? I want to come back to the mode. Okay. Is the screen seen?
Yeah, visible, sir.
Okay.
Visible.
Okay. So just wanted to show that how dangerous are they, but let us not frighten them how dangerous they are. Let us see that one thing is putting the base isolation devices at this column, and which are not costly enough. And also there is another way, at least making some kind of boundary wall. And here you see that how beam and column has to be placed. Designers, they give that they have to be centrally placed, but computer simulation or software, they take some offset which is taken few centimeter or few inch, and they do the calculation how much extra bending moment is there. So in fact, these days many of the newborn engineers that who need not to be a specialist in earthquake or structure, they put any variation in the software, whether it is Plexis or whether it is ANSYS or wherever. They put all sorts of field variations, and then they run the software and they calculate bending moment, shear force, and then based on that, whatever reinforcement is coming out. So this new generation, so-called specialists who have made designers and bring all those things in the design drawing as using AutoCAD and other things, they do not have that kind of experience that if this is not centrally located, if it is offset by few centimeter or few inch, what kind of performance that it does. And also story to story drift, how they are effective, which we take just like a formula. We make a rigid one, and tolerance we set in, we put influence factor or something like that, and we take SA by G, and we think that that pseudo static design is good enough in giving that an impression that our building is it is not going to collapse. But we have not done any such prototype test. Like 6-story building I have shown, you can see 6-story building which is being tested, where screenshot is being shown over here. Again, that how this building performs with all possible technology, know-how, reinforcement, and geometry, both vertical and horizontal geometry, that which is known to the experts that available in Japan. And all those things have been put up over here, and see that how the building is performing. Okay. Yeah. So let me play it just a few minutes only. I'm going little faster. I see that this is a screenshot that I have taken. See that where the failure is happening because of the parapet wall that it is given over here. There is no formula available. It is only through observation and experiment that we are able to justify, or we are able to identify that why the column failed over here, where nothing has happened here in this junction. But why it is here? Because the column, that whatever standard height is there, it was restrained by this parapet wall from the movement that it is supposed to do during earthquake. So if we keep few centimeter gap or few inch gap over here, which is not going to impact the performance of the building, whether it is school building, office building, or whatever it is, so that it doesn't restrain the column, then we can save such building. But yes, it is a structural design has been made and the building did not collapse. But you can see that overall, see the corner column over here. This is a shear wall. We forgot now putting shear wall in a 4-story, 5-story, 6-story building. Because about shear wall, we only study, or some problems are being solved in the 3rd year or 4th year civil engineering. Beyond that, the shear wall concept or other things, and the way that beam columns are placed over here, the way that finishing has been made over here centrally, and other thing. This remains in the hand of the designer, who have become now very much computer simulation savvy, just by putting the input data whatever way they want. But putting shear wall into the RCC building, it is designers' design, and implementation at the field doesn't attract much of the attention. And see that in the 2nd floor. So as per our design code, whatever displacement method or whatever the pseudo dynamic static method that we take. We all restrict such kind of building movement because there is no formula or nothing that to calculate that in the second floor, how much will be the displacement that we can theoretically calculate. But it is theory calculation is one thing, but overall building performance where each and every column, beam, junction, and also that whatever things are inside, it is all mattering a lot. Whatever kind of filler wall is being made and what are the inside things are there. See that what are the impacts are causing over there. It hardly attracts anybody's attention until and unless we perform such kind of, total performance study of a total building. It gives a lot of, sense. And now you see whatever that you can see over here. Now let us go a little bit further in 5th floor. So now you see in the 5th floor that what is going on the same building. So what I wanted to highlight is that though the experiment has been done in 2006 on 13th January, they are still relevant for our engineers and for our designers, for our researchers, and for our decision makers to put some emphasis on making a robust, shake-table kind of system where all kind of structure in prototype way, 1-story, 2-story, 3-story, even 7, 8, 9-story building also people have tested. So in giving an insight into the performance of the building, only having several meetings and committees under CED 39 is not going to help, because there we don't deal with such kind of performance and other things. But the insight has to be given to the research institute like NITs, IITs, or CSIR, CBRI, that work together and create such a robust facility, and then do a systematic and integrated performance of prototype buildings. Of course, whatever building was tested, say, almost 10 years ago, is not irrelevant here. It is still relevant. It is giving us again same kind of lesson that what will happen to our own building if Turkey type of earthquake, which is the context of today, comes here itself, and which is all possibilities there. So let me go back. I think not much time is I should take. So this is what that even such kind of things are there which are waiting to go wrong. And also there are some star rated building, green rated buildings are there, and we have Griha system and other things, which civil engineer has hardly any role to play. But when they are rating a building like this, and over and above that, so many architectural marvels are there in the country, but structurally having a robust column and then connected to such kind of slender at one corner and other way, geometrically they are totally disconfigured, but still they are star rated buildings. And so performance of such kind of buildings have to be noted. I think the next lecture will be on such areas, the rapid visual screening. These are the aspects that which is to be highlighted, that these are not the type of building to perform that satisfactorily, even though finishing and other thing, all kinds of star rating, green rating, 5-star, or all this rating has been done. Until and unless it is connected to the structural things, especially in earthquake prone area, that they are not going to survive. And you see structures that we are making. Of course, these are the numbers that you can see in my Facebook that I try to highlight without pointing to anybody. Who have made such kind of thing that no columns are there. Of course, design has been made. Design has been made, taking that, not taking any support of the continuous support of the column in this part, and accordingly, whatever, when it is made, So they have distributed, building is existing. But such kind of disconfigured geometry, even if enough computer simulation or computer ANSYS or Plexis or ETOP calculations has been made by removing a column, uh, uh, not taking a column and making that here it is 0 or whatever combination that present day software simulation specialist that without knowing that how they are going to perform, ultimately they are going to be revealed such kind of blunder that which cannot be simulated simply by computer. But when earthquake will do the simulation on such building, then it will be revealed. So especially post-earthquake surveys, generally when the building history are not known, then the kind of judgment that sometimes we often give, they are fallible. And not having column at the corner is being revealed by earthquake. Just previous example, it is yet to face any earthquake, but not having column can be seen here that not having column at the corner. So it is a must that we should have. And also in Guwahati itself, having such kind of bracing in such building is the norm, and it doesn't cost much. So by adopting such kind of things in Northeast, many such adoption have been made in this manner, even in RCC building. But that has to be made into the regular practice. So now this is in Noida, Delhi, or wherever we go, NCR area. Just simply by recalling that we are in seismic zone 4 or 5 is not that giving a memory test to somebody else or memory test to the school or some of the quiz and other things. Somehow we get a self-satisfaction in recognizing or teaching our students that, oh, which zone of earthquake you are. I think, or sharing that, oh, we are in earthquake prone zone 4. Oh, you are in 5. And such kind of sharing doesn't mean anything for the engineers like us or professional like us. We have to see that these are the most dangerous one. And in that case, what are the measures to be taken? That is simplest measures, which is being suggested in one of the book available for the last 10 years. You see, this portion, like multi-story buildings are there, keeping the facility of the parking over here without disturbing the parking. This red colored portion is simply a 10-inch width brick wall. And you can calculate that how much cost of this brick wall. And if, say, for a 20-story building, 4 flats are there, like the P Tower I'm talking about in Noida, 80 flats. And if 80 flats, they are paying 5,000 to 7,000 rupees as a maintenance fee, annual monthly maintenance fee. This may not cost even 1,000 rupee extra for them as a one-time money to make this kind of wall over here by no skillful masonry or anything, simply making wall. It will give certain amount of reliability on the buildings which are having such kind of defects, which cannot be justified by computer formula or anything. Let run the computer or DeepMind or whatever computer simulation that we are doing, those will be proved to be bogus if we try to justify being from the education or research institution that our computer simulation has given with the seismic zone 4 earthquake, these buildings are safe. I don't think there is any civil engineer or any expert born or would be born in the next 100 years to justify such kind of buildings that they are safe enough against earthquake. Let there be whatever may be the amount of steel being provided. So only way to lessen that I would like to end here is that when we cannot avoid such kind of construction, when so many constructions are being done, when putting a base isolation at each and every column over here becomes a tedious job, and it is not easily affordable because we do not have proper information or proper performance of the foundation, because foundation has to perform uniformly then in that case, at least for satisfaction or sense of satisfaction, at least before going for some kind of disaster insurance and other thing, well, that is not going to make us until and unless we at least take such kind of measures, and that should be the gateway to taking lessons and taking some small measures which will make sizable difference in saving such kind of buildings. So I think it is good that otherwise we are not going to learn much, because there are a lot of things or constructions and even early warning and other things. Let us not spend too much of time in early warning, because in 30 seconds or 20 seconds of early warning to earthquake, it is not going to help until and unless we make our building seismically resilient enough. Because early warning part, it needs a lot of things IIT Roorkee has developed. In fact, there was an exhibition here in NPDRR yesterday and today, but it is still miles way to go ahead to make it to the public. But there are certain countries. But most important part is that identify the building, whether in many area, and check them whether they are seismically qualified or not. Rather than making or putting a quake alarm which are available in the market without background system, proper reliable background system like this, we cannot just think of imagine that we will stop train the way using early warning that Japan has been doing for more than 2 decades. And so it is not going to make us. First thing is to identify the diseases, diagnose diseases that caused by our faulty construction technique, and also mark them, sensitize them, which is our goal from NIDM and with all the state government and everyone, that sensitize each and everyone with the kind of defects that we are able to identify by visiting a constructed facility, and also stopping or modernizing our surveillance system using digital construction technique, digital construction system, surveillance system, that what is actually going on in the site, taking photographs and other things, animation, drone survey. We have gone far ahead in surveillance and getting every millimeter increment in the construction every day or every hour. So we have gone far ahead in that area. But we should not forget that this is to be taken with a very, very strong sense of, I would say, sense of, pledge that we have to take today, while recalling that what happened in Turkey, and then taking it in our country's context. Thank you. Because this is the real train that they have stopped in Japan in 2004, mid 23rd October. I was there at that time. So these are the way that they can stop, because by whatever investment has been made in developing the early warning system, you see, one such investment, they could save a train or even many nuclear power facility, gas line, they have got a dedicated system. So this was running at more than 250 kilometer, speed, but stopping them automatically within 5-6 seconds, which is we are not going to achieve anytime near soon, to get the location of the earthquake and magnitude of the earthquake within 3 seconds. We are nowhere near to that kind of instrumentation in our country. Entire country are having less than 200, whereas Japan, they have more than 10,000. So we have to have now IoT system. There are many accelerator that IoT systems are being applied, being checked. Even our mobile accelerometer are being used, so that we don't have to go for a heavy investment that in installing that seismic stations at a grid point of 15 to 20 kilometer, which they have made more than 2 decades ago. Let us not go by that path. Let us take via media with whatever sensors that we have, whatever stations that we are having in the Himalaya area. We can substitute some of those, not substitute, rather we can place some of the IoT sensors, accelerometer in place, so that we can catch the earthquake early. And already algorithms and other things are available plenty across the globe to catch the earthquake within few seconds, because every second earthquake travel 4 to 5 kilometer, so that we can get early warning. And we are already familiar with controlling our satellites and other things, or shopping door mall and everything through a remote sensors and other things, and giving all those control system we have. So we'll achieve this one. But since earthquakes are not so much frequent, it is more important will be to check the vulnerability of our building establishment and take a mass scale, application of the codal guidelines in making our structure, our buildings and construction, future construction resilient enough. Thank you.
Thank you, sir. Nice and a very interesting manner you have presented the whole thing. I really appreciate your interesting way you have presented and critically analyze the things, whatever the knowledge we are having right now. You have critically analyzed the things, the disaster and everything, and you have provided so many informations. And from the point of view of not technical side, from the point of view of social aspect also, policy making side also. We are thankful to you, sir, for your kind and motivated words with this presentation. So before going to the next session, actually I missed out your brief introduction.
No,
So
it's
just
not
I
required.
take few minutes. No, I just, it's the customary thing. Others are there, many people. I'm just quickly going through. Professor Chandan Ghosh, a civil engineering graduate from Bengal Engineering College, now IIEST, Masters in Civil Engineering 1987 from Jadavpur University, PhD from IIT Kanpur 1992, and Doctorate of Engineering from Ibaraki University, Japan, has been serving NIDM, National Institute of Disaster Management, Ministry of Home Affairs, Government of India, since July 2006 as a professor and head, Resilient Infrastructure Division. He served Faculty of Civil Engineering at IIT BHU in the tenure of 1990 to 2000, did postdoctoral research in Japan, and was on deputation to IIT Jammu since September 2019 to December 2020, where he served as a Dean of Student Welfare. Professor Ghosh works in the areas of earthquake geotechnology, reinforced earth, seismic microzonation, ground improvement techniques, geosynthetics, and bioengineering measures for sustainable developments. He has devoted more than 30 years of his career in EG and PG teaching, research guidance, development of teaching tools and training module for engineers, architects, town planners. He has published more than 135 papers in reputed journals, conference proceedings. As recognition to his seminal contributions, he received Leonard Prize for the best doctoral thesis in 1993, CIDC Visakhapatnam Award 2013, IGSC AC Burma Golden Jubilee Award 2013, Lifetime Achievement Award 2019 by IGS Delhi chapter. With this brief note, I would like to thank you once again from our side, sir, for giving a valuable time from your side. So just now I would like to invite now the next, our last speaker for this today's evening, just with a small brief intro about Mr. Manish Bharti. He is the basically CEO of Cortex Construction Solutions Limited. Mr. Manish Bharti is a structural and diagnosis consultant since 2006 and a member of ACI, American Concrete Institute. He is currently CEO of that company, Cortex Construction Solution Private Limited, which is a leading private company in his domain and has been known for his innovative structural audit approach through the various diagnostic systems. His primary research interest lies in the understanding the behavior of structure, material characterization, development of diagnosis systems for all kinds of old structures, and designing suitable repair and revelation techniques. Instrumentation and load rating for the structural for the operation load. He has been involved in a wide range of consultancy jobs for rehabilitation projects, more than thousands of structures from industrial buildings, bridges to heritage buildings. So with this brief note, I would like to invite Bharti ji to take over the platform. Over to Bharti sir.
Thank you, sir. Good evening, everyone. Good evening, Chandan sir, for calling and giving opportunity. So let me start with the one brief presentation. What kind of services we are providing. Then we'll explain in details which way we can give the technical support to industry, academic, and the applicant or the engineers or the building authority and building owners, how they can conserve their building, how they can make their building safe, and habitant for purpose for different criteria for earthquake or live load, dead load, some kind for cyclone purpose, or some kind limited load for operational load, for modification load. So there's a lot of the objective. According to objective, we give the diagnosis services, and on the basis of diagnosis services, we characterize a lot of parameters, which will require some time for architect, which will require for some time for academic research purpose, some time for structural engineer, and actually it starts generally the basically we'll talk in details about the diagnosis services, but just I'm sharing here. This one is the structure, adequacy, and residual life assessment. So how we start this kind of assessment? So generally, Cortex provide the services in these area. First in the building, which may be related to the RCC structure or steel structure or masonry structure. And we also provide services in heritage. The heritage may be related to timber, unreinforced masonry, reinforced and unreinforced. And below the earth, sometimes we do the services related to the foundation investigation. So generally, we are unknown about the type of foundation, depth of foundation, and their integrity. But still, we want to know about details about the foundation details. We have such kind of diagnosis system. We at least can give the idea about the depth, sizes, and but we can't give the details of the reinforcement or the grade of concrete, but definitely we can give the depth, size, and section size. And now we are coming in the industrial, so we can give the all kind of the parameter related to analysis. If you want to do the analysis for the chimney, silo, bunker, or machine foundation, or the steel frame structure. And then infra and bridges, we have a lot of the sensors and IoT instrument and instrumentation systems by which we can define the load carrying capacity. And also we can give the impact assessment, vibration assessment, and the behavior of bearing, expansion joint for the any kind of bridge, maybe the arch or the RCC cable, and from rail to railway. Now we start agenda, how we start the services. First, whenever any query will come at our table, we start with the visual condition survey. We used to go at the site, and we have a lot of the mobile application, and also we have hard copy performa by using it is also prepared based on the lot of the codal provision. Maybe sometimes we are using the FEMA code or the steel code or the masonry code, or for bridges we are using the IRC. And for diagnosis, we are not limited for the only your BIS code. We can use the ASTM, sometime ASME for the steel structures. We also use DIN code for your German and European based company. And we start with the visual survey. So they have a lot of performa. That performa in digital form we have converted in our application form. And we start with the survey along with the photography, preparation of diagnosis plan, and damage classification. On the basis of the damage, we define the which type of test will be recommended. And there's a two type of test. One is generally for the material characterization. So material characterization is mostly related to the property of materials, but it may be not related with your failure behavior, failure type or the behavior of the structure. So according to the behavior, you have to select the different diagnosis system. As per material characterization, you have to select the different diagnosis system. So the survey and the condition survey is a very primary and necessary steps to start any kind of investigation, because on that basis, we generally select the type of the test. And after the visual conditions, we just recommend the type of test to the building authority or the associated technical committee. to find the reason behind the material degradation, cause of distress, and vulnerability, whatever the parameter required for the vulnerability analysis or the ETAB model or the STAT model. We can provide the all kind of parameter through the diagnosis system. On that basis, even we can predict the residual life of any kind of structures, but it is not generally in terms of the life of the performance. It is generally in terms of rate of the corrosion, rate of loss of your section size, rate of loss of your, for example, this is your metal plate or the some ISA or angle. Right now, for the analysis, you need the 45 by 45 by 6 mm section thickness. But on that basis of the corrosion analyzer, we can predict how within the 10 years or 15 years, your section size will reduce from the 6 mm to 4 mm. So if it will become the 4 mm, so what will be the effect on the overall structure stability? So now the all kind of the assessment to the material characterization and the behavior, and even we can define our behavior in terms of the forces. Force is the main parameter. For example, if I want to define our structure in correspondence of the only dead load or the existing load or non-operational load, their analysis will be different, their stability will be different. But when we analyze any kind of the existing structure in terms of the operational load, for example, if there's any monument, but I want to convert that monument for the museum purpose. When we convert the monument for the museum purpose, in that case, the live load will come in the action. So we have to analyze the stability for the upgraded load, not for the initial or non-operational load. Again, when we go for analysis for the all kind of the earthquake or the seismic or cyclone or the wind forces, then our analysis and the outcome of analysis will be different. So there's a failure component, failure type of the failure, number of the failed members will be different. So always we have to keep in the mind during the investigation for which purpose you are doing the diagnosis or for which purpose you are going for through the analysis. Or that will be define your condition survey, that will define your type of diagnosis, that will also define type of the analysis required for assessment. So if I want to go for the only dead load, live load, then we'll go for the ETAB model. Sorry, not generally for the STAT model or the fixed point, fixed nodal, fixed junction will define. But when you go for the some kind of the sway or your drift ratio, then we have to select the analysis for the by the ETAB model. But again, you want to behavior in the stress analysis, or for the if you want to check the concentration of the stress, if you want to check the deflection as the in terms of the strain, not in terms of deflection. In that scenario, we have to go for analysis for abacus and ANSYS. So actually, we are in the commercial field. It depends upon the our exercise depends upon the requirement and necessity of demand of the client first, then how it will helpful to the client, then how much client is paying to us, and how much time client is giving to us do the all kind of exercise. So in that all factors, we try to figure out our approach 1, 2, or 3. And if they have limited time, limited budget, then we give the option to the client, which way we can give the assessment report to the client. Now we are coming to the repairing system. It is okay for after analysis, your building is not safe or safe. It is safe for only that much load, or this is not safe for the earthquake load. So, but actually our client or authority is not concerned about which member is failed or pass. It is a passing, falling in the passing criteria or beyond the passing criteria. They are much interested it is safe for habitat purpose or not. If it is not safe, so how we can make it safe? And if you want to make it safe, so how much cost will come and how much time will be required to make it safer? That is the main objective of the client. Client is not worried about which type of diagnosis you have adopted, which type of model analysis you have done. There's only concern I'm safe inside house or not. That is the main objective of the all authority, all client, even the government. So actually from the diagnosis, we start to the characterization of building and the type of members. For example, if it is a, RCC frame or the composite structure, unreinforced or the steel structure, or it is random behavior of the structure. For example, at the plinth level, you have adopted the RCC frame. At later stage, you have used only the composite steel structures. So their behavior will be different. Even in the roof, our the flexure member type of the RCC roof or the RBC or a brick wall or arch or jack arch or dome, their behavior will be different. So we have to modify the load bearing member, which is the transferring all live load through the vertical member to the foundation, either different. And when we analyze your horizontal member, flexure member, their analysis will be different. Because when we are talking about the masonry structure or unreinforced masonry structures, in general, in the unreinforced masonry structures, most of the critical or catastrophic action is a result of the outplane failure or inflane failure. So outplane failure is mostly related to your type of the roof. Your roof is the flexible or the rigid. It will define the failure. Now, so this is the why investigation or the condition survey is required. I want to explain. Now I'm coming to the characterization of structure vulnerability and strengthening approach. So there's a two type of approach generally required by the client. First is the whatever the failure is visible at the site or in the building. So they want to restore their building for the original capacity for which it was designed. So when we go at the site, we generally identify type of behavior. It is material degradation or non-structural failure or the structure failure. Just giving, I'm giving the simple example of the structure failure defined in the IS 456. IS 456 is telling if your crack is more than 0.3 mm, then it should be defined as the structure failure. But if your crack is below the 0.3 mm, it should be considered the non-structure failure. But same thing is not written for the composite structure. It is not written for the masonry structure. Now I'm coming for the type of the crack. How will define the width of the crack and length of the crack? For example, if your width of the crack is only for 1 meter, and if your width of length of crack is the 3 meter, which will be the dangerous, is more danger in compared with the another one. So it is not defined anywhere. If I am measuring any width of the crack at certain distance, for example 500 mm or the 1 meter distance or 1 kilometer distance, their intensity of the width will be different, because we are going to do the investigation for unapproachable location by the drone. So drone angle, drone location, drone distance will define the width of the crack. So so how will define the width of the crack? So we can't touch all kind of the crack with the simple by the telltale meter or some glass strip. So we can't install in that way. So we have to also define how we'll do the crack investigation. And if your crack in the flexural zone in the center, so which will be danger? If that crack in the shear zone, so how will define the intensity and which will the more danger? Now, if I'm going to define the crack, for example, so this is the minor, it will require the minor repair. It is a part of the routine maintenance, or we need the structure strengthening. So if there's a material degradation means thermal crack or some kind of the dampness or the spalling due to the corrosion. It may be the minor repair if it is localized. But if crack is throughout in the column, it is reducing the diameter of the your reinforcement. That is not the minor. It will not demand the minor repair. It needs the structure strengthening. if your there's just some plumbing failure, or the some seepage, or the failure of expansion joint, then that is a part of the routine maintenance. It is non-structure failure. So your chhajja and fence is the non-structure member. So generally people call this is non-structure failure if there is some corrosion or some spalling in the chhajja and fence. But once chhajja and fence or the parapet will collapse on the all the walking people inside your campus, that will call the structure. So now we are coming on the specific to the structure component, specific failure in terms of steel percentage or section size. It is a localized failure or global failure. We need the external support immediate, or do we need the major structure strengthening? It is internal strengthening required, or we have to restrict the live load for time being, so that load will not impact further to deteriorate the load carrying capacity of the structure.
Your slide is changing, or I think you was stick to second slide.
No, sir, I am coming on the restore for the.
Okay. Okay.
No, sir, I'm coming the restore for the enhanced capacity. So once if you want to enhance the capacity for the new design, so once you want to enhance the load carrying capacity for the new codal provision, most of building will be failed. Most of building, because it is not designed, not constructed as per the new code. So if I want to go audit, I want to upgrade our building. If you want to submit assessment report as per the new codal provision, so your report will be different. But if you want to get the report as per the old codal provision, their report and type of percentage, type of failing member, nature of the failure will be different. So now I'm coming, sir. So this is the 4 parameter. First, the visual condition, material characterization, structure analysis, then repair and DPR. Now, why the diagnosis is important? So diagnosis gives the cause analysis. And second, the diagnosis gives the volume of distresses. How much the area is the corroded. So sometimes you can't see the corrosion, whatever going inside the structures. But by the certain test, you can identify where corrosion is not visible, but still you can identify the hidden corrosion inside the concrete. And the material property. If you want to know the material property as at present date, for example, grade of concrete, steel percentage, stirrups spacing, and section size, foundation details, whatever you need for the model analysis, all kind of data can be generated through the diagnosis system. Now, sir, this is generally whatever we final solution give to the client. We give you need the periodic maintenance system to minimize the deterioration rate. You need the retrofitting cost with detailed BOQ, material specification, rate analysis as per the optional retrofitting scheme as per client budget and upgradation requirement. So optional retrofitting is the, for example, I don't want to upgrade as per the seismic, because I know I can't upgrade it, but still I want to upgrade it for the live load. So there's a repair scheme will be different. If you want to just keep the structure for only 2 years, but after 2 years you want to demolish and reconstruct the new structure, their repair scheme will be different. So as per the client budget, we generally define, even if you want to upgrade the 100% building for the new codal provision, so I can define that vulnerability index, which column and the beam should be strengthened in the first budget, which a section or the floor or the type of member should be upgraded in the next budget. So that vulnerability index can be also defined. And finally, we'll issuing structure stability certificate. Structure stability certificate is not for the seismic load. Generally, we define and maintain in our clause, this structure will say for the this structure behavior will be in this pattern for the for this kind of that much of load. If you want to increase the load without any further investigation or analysis, our structure certificate will be invalid. And this certificate is only valid for the live load, dead load, not for the seismic. And if it in deterioration condition, So generally we mention this building, if same kind of the crack or the deterioration will appear within the 2-3 years, you have to call the structural engineer to investigate the site. And if you don't call us or inform us in advance, in that case our certificate will be considered invalid. So this is general approach we generally use to we use this kind of the approach to do the structure audit or structure assessment. So I am showing one example how we have done for the Maruti plant. Recently we have submitted one report, and this is the one building in Maruti. So just saying the structure audit of existing building for Maruti Suzuki Limited. So this is Maruti Suzuki. Actually, this is your repair shop for the Maruti, and where the most of the cars are in the repair shop at all floor. So there's a load is more than the 1500 kg per square meter. So we started with the diagnosis. So for diagnosis, sir, we have adopted first the visual inspection. For the rebound hammer, only we can't extract the code from all location. So we for the correlation with the code test, we adopted rebound hammer. Ultrasonic pulse velocity only adopted for the density and the porosity inside the concrete. Code test we adopted for the grade of concrete. Cover test for the minimum the protection of the reinforcement and the from the fire. That for purpose we use the cover test. Carbonation is the only for deterioration factor from environment or the because it is a car shop, so we adopted the carbonation effect of carbon dioxide on the concrete. Resistivity for the corrosion, pH test for the original type of the water used in the construction. So maybe the corrosive factor inside the present in the original concrete. So sir, we started this kind of test, and this is the code. So you can see the criteria. This is good to very good, the hardness index, variable quality, or the uniform quality. So we adopted the statistics form. This is the pie chart and the histogram. For that we can give the try to understand the nature of the behavior. This is a uniform concrete material or the variable, or at the different level in different member they have used the same concrete, or the concrete grade are changing in respect of the floor or the type of member. And what is the coefficient of variation? For the USPB also, sir, we try to find out the porosity and the permeable nature of the concrete. So this is on the doubtful to good variable, doubtful to good variable quality. So these way actually again we have plotted. So there's a 40% the good nature of quality, 20% doubtful, and medium is the 38%. So these way actually we have done a lot of statistics analysis. For the also grade of concrete in the basement, we have M20 to M25. For the ground is the M20 to M25. First floor we have actually we have the M20 grade of concrete. Same we have done the so these way actually we generated the data related to the all material characterization or material property related for the analysis purpose. So now sir, we can also generate the drawing. If you don't have the drawing, we have a lot of GPR, hand GPR, and laser system on by using those diagnosis system, we can create the not the 100%, but at least 90% we can generate the equivalent the structure drawing related to the building. And so such way, sir, you can see here we have generated RCC details for the column. For a different type of column, there's a size of and diameter of reinforcement. Even the for the beam we have now, sir. This is the visual survey. You can see the type of the there's a crack. This is a general spalling. This is a dampness and localized corrosion. And now, sir, we are coming on the one. So this is a crack in the column. Now the dampness in near the bathroom, and I'm coming another the spalling. So there's a failure nature the expansion joint. You can see the and the crack between the joint masonry and the beam due to the incompatible nature between the brick and the reinforcement. And this is a corrosion crack in the column. And similar, sir, you can see the spalling of the concrete and the recent floor. So this is, you can see the corrosion and the loss of the reinforcement and diameter of the reinforcement in slab. So such ways, sir, actually we do the investigation and we try to find out the region where the only particular region there's a corrosion or spalling, not why it is not uniformly. So these way actually using the different chloride content or the pH or the dampness or continuous channel of water, identification of continuous channel of water, we generally trying to figure out the region behind the all kind of distresses. You can see here, so near the expansion joint, there are a lot of the corrosion in the beam. So these events are where the bathroom area, you can the seepage. So these the generally condition assessment. And now I'm coming, sir, on the this is the model analysis. So this is the our structural analysis report for critical section of Maruti building. So we have not analyzed the whole building, but it is only one region where it was separated with the expansion joint. So, sir, we have also constructed the same location, the water tank load, staircase, column, frame, whatever the original operational load. We have also mapped the floor load at each floor. That load was imposed at the each floor level. So now, sir, this is the methodology. You can see these codes were used during the analysis. And now, sir, I'm coming the specification of building for the section size, their width and depth and concrete grade and type of reinforcement. And that was same model in the ETAF. And now, sir, I'm coming here. Same model was prepared in the ETAF. This is a floor plan. And this is a frame, whatever we have shown in the ETAF model. And grade of concrete, whatever we have assigned in the material property tab. And sir, then through the analysis, we have imposed the type of load combinations. And these load combinations, from that we generated the base reaction. And from base reaction, we analyzed the foundation capacity of foundations, bending moment diagram and axial force diagram. From that actually and lateral forces will also impose as per the your geographical details. And on that basis, sir, we have also you can see here the model mass we have created. And on that basis, sir, at the last we have checked the drift check. So you can see at the terrace level, these are the failing in the drift and the first floor, but the ground floor is passing, and multi level is also passing. And this is which generated the maximum story drift. And which column and which beam is failing, that is already highlighted with the different colors. And this is also we have analyzed in constant of demand and capacity ratio. And this is the executive summary. So you can see the column beam slab. This is deficient in reinforcement, no, for the only dead load and live load. And structure demand of structure repair not required if we are analyzed and you are releasing the structure stability from the only dead load and live load purpose. Now, sir, if I coming for the live load, dead load and earthquake purpose, you can see here column is safe in deficient in section size, no, deficient in reinforcement, yes, demand of structure repair due to the design deficiency, all column marked in the red color demand repair. And demand in section size for beam, no. And in the slab, sir, you can see here there's no demand of structure strengthening, but we have analyzed, we can't increase the load more than the 400 kg per square meter for the operational purpose. So these way actually we analyze the whole building. So actually, I'm showing the one typical. So actually, that time Kaushik sir and Chandan sir also explained whatever do analyze or the construction. It totally depends upon the whatever construction methodology or construction detailing of the reinforcement adopted at the site. It matters. It defines your structure stability. Just sir, I'm showing one photograph, and you will not believe this building belongs to one of director. He's the IAS officer, actually in the Ministry of Commerce, and actually this house belongs to him. And for the reinforcement, once he made a call to actually sale director, okay, I want to purchase the reinforcement, and which will be better in the market. Now, but whatever sir, construction was done by the also he hired one good contractor from Noida. But you can see the quality. Just I'm showing. You can see the reinforcement. It is totally exposed. So you can see the quality of the compaction of the concrete. Even that grade of M30 grade of concrete used for only G+2 structures. And you can see the here compaction of the concrete. Now, sir, you can see the hollowness in the reinforcement, and it is a column located in the column beam junction. And now, sir, I'm coming here. You can also see the condition of compaction of the concrete. This is the, now I'm coming here. You can see the quality construction in the shear zone, where the maximum mass is at the junction. You can also see the compaction of concrete in the shear zone. And you can see the offset of verticality and plumb line of your column. And so this is the condition of the column in junction. And now, sir, very interesting. If you see here, now I'm coming to the last photograph. Even sir, you can see the junction of the column beam here. And last, I'm coming at this position. There's a, sir, it is a column here in the at the ground floor level. At the bottom, you can see they had put the brick. So when we had some doubt, so I excavated that location. So even that column was directly, they rested on the plinth level. And now, sir, that person, even he is powerful, but even he has compromised to go with that same contractor after the some modification in the building, some strengthening measures. They are ready to adopt the building. So this is the condition. It depends. It is not only you are going to decide the future of the building, stability of building, life of the people. Even if they have put the CBRI here for SK Singh sir at this site, they asked the director of NBCC for diagnosis. They had asked to us do the diagnosis. So even so that much he can call that much of caliber people. But actually, whatever the stability will be definitely be decided by the contractor who has taken this job, who has taken the responsibility. Even sir, I'm going to show one very typical structures. You have heard about Sika, Fast Rock. They are giving the repair technique for the lot of the construction building, where the most of building are failing, crack or the corrosion, whatever. Even their R&D area, I'm showing here. This is a shear crack in their R&D center. Sir, your crack between the beam and the wall, masonry wall. I'm coming here is a shear crack, and the floor crack. You can see the crack at the floor, and the throughout crack in the masonry wall, and the width of crack you can see here, and so crack along the beam at the top of the beam. You can see the crack in the floor, and shear crack in your also beam. Upliftment of the slab. You can see this upliftment here. So And so you can see the even the external wall and the outer wall. There's a lot of the crack. So, only even we are aware about the possible failure. We are aware about the what kind of mistake will be done by the contractor or the designer, and even it is under execution or under repairs. Even we can't uncertain, we can't certify that building will be stable for the seismic forces. But yes, we can characterize type of the methodology adopted, type of the construction technique they have adopted at the site, how much detailing, type of detailing they have adopted at the site, and what is the rate of the failure, what is the rate of the corrosion, type of the failure is visible in the building. That can be definitely characterized during the pre-disaster survey. And when any kind of disaster will occur in the any part of the world, we should visit at that site, and we should try to simulate which type and which kind of material was adopted, and even that is okay as per the present code, why that building got collapsed. And that will give the parameter, because whatever the failure we are checking in the control environment will be different. Whatever the parameter we are checking at the ground level, their behavior, the nature of failure will totally different. So once we do the simulation of the industry in our lab, and that if will failure is changed in the empirical formula or in scientific or mathematical calculation, and that formula should be again incorporated in our codal provision or code or investigation document or assessment document, that will definitely helpful for us. And for that, actually, we'll try to call a lot of ministry, and also I was continuously in touch in Chandan sir. So we had developed one app, mobile application. Just I'm sir show one. This is our. So this is one application, resiliometer. And in resiliometer, we have a lot of dynamic features. So according to that, you can select the type of disaster, earthquake, or you want to do the survey for earthquake or flood or cyclone, you have to select earthquake. Now we have assessment method for NDMA or IIT, FAME, or whatever code you want to. You can change the questionnaire according to codal. Even you can change the score of the answer against the questions. Now, sir, I am coming. Now the type of structure you want to go for RCC, steel, or masonry. So now, sir, I will come in another page. And from that page, you have to select your building. For example, I'm selecting IIT Delhi here. So I'll come here at the IIT Delhi. So they will ask, it is your building. I'll confirm yes. If I'll ask yes, they'll automatically they will give us the they will fetch it from the Google data. It is altitude or longitude and microzonation. For example, if I'm selecting here the state, for example, Delhi. In Delhi, it is in the South Delhi. They will give the, for example, it is a local, wrongly map here. So they will give John 4 or John 5 or some type of the same. And here I'm going to the IIT Delhi. Now, sir, I'll come here. Honor, for example, Manish Bharti House. Now, phone, mobile number, if I'll put here. So, sir, I'll come on this next page. So, even I can start the camera. For example, if I'm investigating this building, So I'll select this one, and this is our profile picture. So you can take the picture from your camera as well from the gallery. So it depends upon you. And such way, actually, we can also put the caption for the is it plan or the elevation. For example, if I'm taking the one picture here from now, this is a so from gallery. Even from gallery, you can select any picture. So if I'm taking this RCC detailing or if any kind of the now. I'm so randomly putting because within 2 minutes actually if I'm taking the for roof or something, so you can give the caption also. So such ways are actually now will come on the image plan elevation you can upload in your server. Now the question will come according to type of nature, type of building, type of disaster they'll ask. So then you have to select the mandatory question. For example, I've selected here 2 questions. It is a floor level no and double structure only, and I'm escaping the rest question here. Now, sir, coming the technical information again, sir, I am coming the grid line. Yes, there's a grid line, and this is a yes, and now, sir, I'm roofing material. I'm selecting the RBC. For example, for just now, I have selected 3 questions here. And here there's a one mandatory. There's a corrosion in the yes. And at the last, sir, I'll select the plinth level band present. No. If there's a soft story, no. So now I'm coming the some failing hazard from the geological hazards I've selected. Now, sir, I will come on the condition survey. So this is the condition survey related post-disaster or pre-disaster. You can select as per your requirement. If you are using this app for the post-disaster or the pre-disaster. For example, I'm selecting for the pre-disaster. So you can select the distress pattern. And for distress pattern, you can take some photograph. For example, I'm taking this photograph, crack or whatever the corrosion. You can also give the details here. And similarly, sir, I can take from the gallery also. If you have some selected photographs in advance, you can take from here. Now I am taking the type of the column. It is a steel column, or the type of member. It is RCC column. And urgency of repair, it is immediate repair or immediate load restriction, no, immediate demolish, whatever you can select from here. Now, sir, it is I'm coming the damage. It is a low, mild or severe, immediate failure or demolition. So you can also select the damage scale from here. Now, sir, I'm coming the environmental. It is a moist or dry, mild corrosive, severe corrosive, exposed to fire, or exposed to some cyclone. You can select. This is a non-structural failure or a structural failure. You can also select from here. Similar, sir, in one screen, you can take the 4 photographs. So you can add according to your demand. Just I'm coming here, sir. So you can also conclude your root cause analysis here. And what is restoration methodology at only on the basis of visual survey. For example, I'm recommending RCC jacketing. Now, concluding remark, restrict the load. So, sir, now this way actually you can add more also. There's an option, or you can just escape that one. So, sir, now I have one picture post disaster real. So I have I have finished this survey. And when you have finished this survey, so you can view the report. And you can see here automatically, you can see I have taken these photographs, and I took the IIT Delhi, and then 2 questions I have attempted for this. And for technical information, grid and flexible and RBC slab, I had selected. Now the disaster and even for the condition survey, I can automatically get the total score, how much signature, your immediate action required, expert review required, comments in good condition, available grid, or the and so these are the condition survey you adopted. And this is a restrict the load or the RCC jacketing or whatever recommended, that will be come, and you can share that report through the mail. And also you can download the report, and you can share with your expert. So these way you can generate the lot of data, and that data will be very beneficial for us. And which way, sir, actually we can generate the thumb rule for the some habitant or the owner or in the rural area where the people are not able to afford the structural engineer or the architect, and where our authority or our technical expert, they don't have limited reach to give the such kind of services. So from the industry, we should transfer to the academic, and academic we should transfer to the policy maker and guideline maker. This is the best way how we can improve our system, and we can support our who are looking the some kind of solution from us. Thank you, sir.
Yeah, thank you. Thank you very much, Manish ji. You have really shown some case studies with a lot of new ideas about the auditing, structural auditing, health monitoring about this. So it's a really good presentation, and way forward towards this seismic vulnerability assessment studies. I think we have come at the end of this program, and this is there we can find few questionnaires also. We can find many of us has some questionnaires. So I'm quickly going through some of the questionnaires for the today's panelist first. So here we can see somebody has remarked like this, Wesley Pereira, I think Professor Kaushik. So I just take few questions. How does the load applied in laboratory to measure displacements correspond to observed magnitude of earthquakes? Is there any relationship between the two? So I think Professor Kaushik sir, I think you can also see these questions, right?
Yes, I can see this. And this is very good question. So the testing, most of the tests that I showed were done on a very slow cyclic manner. So what happens in this case, we don't consider the influence of inertia and damping, which are two major effects in case of earthquakes. So what we consider then, that the tests that are carried out in a slow cyclic manner using the servo control hydraulic actuators, these will give me the maximum possible strength of any structure. So obviously when the structure is tested by the earthquake, the strength will be less than that. So this is the upper cap that will be obtained using these tests.
Okay. So so actually Wesley has want to know about the magnitude of earthquake. It means he or she wants to know about the, I think, how we are correlating the intensity of the earthquake with the experiment, I think.
Actually, there is no relationship between the magnitude of the earthquake and the loading that we apply in the laboratory, because we don't design the structures for magnitude, right? We design the structures for the intensity.
Yes.
So there's no question that these magnitudes are actually related to the load that we apply on the structure.
Oh, so sir, whether I have a query regarding the servo hydraulic actuator. These actuators, sir, you perform the test. Is it stress controlled or that means displacement controlled?
These are displacement controlled.
Displacement controlled. Okay. Okay, quickly, I'm going to some of the other questions. Rishabh Singh, he has asked, I think to you itself, what do you define as failure in your experiment as in case of ICRA wall horizontal loading?
Yes, another very good question. So not only in case of ICRA wall, in case of any test that we do, defining these things is very tricky. So failure, for example, can be failure of a single column in a building, or it can be failure of a group of columns. So we have to assume something. We have to define at the initial stages, like how do we define the stiffness? How do we obtain the strength? How do we obtain the failure? So in this particular case, we define failure as the reduction in the strength of about 20%. So if the strength reduces to 75 to 80% of the original strength, we define it as a failure.
Another question he has asked, Rishabh Singh. Are there any initiatives taken from policymaker side to standardize the vernacular traditional construction practice? I think this question is for both of you, I think. So you can attend, sir.
Not really. I don't know if there is any initiative by any policymaker. I'm not aware of anything.
Yes. Then another person, Chandrababu, has asked, what will be the type of foundations used in Assam type buildings?
Okay, so there are two components in Assam type houses. One is the masonry wall that is there up to the sill level. So below this masonry wall, the type of foundation is similar to the type of foundation we provide for unreinforced masonry. So basically a thicker wall is there below these walls. And below the main posts, these are the timber posts, we have either masonry pillars or plain concrete pillars up to the level of the brick wall.
Right. I think there is another very good question from Bipul Rumta. We saw during Turkey earthquake that most of the story failed due to soft story at basement. So what kind of infill should we adopt at basement parking area to avoid such failures? Yeah, that's a very pertinent question.
Okay, so I think this question is for Professor Ghosh because he spoke about the open ground story buildings.
Soft story, yeah.
Yes.
I think Chandan sir, you are with us. I think he has to attend a meeting, he told me.
Okay.
Okay, no issue. We can also answer him regarding Turkey. Soft story is a very...
Yes. See, soft story is my area of research, of course. So if Mr. Vipul is asking about the particular type of masonry that we should use, so there is no, hard and fast rule. Our code allows us to use first-class masonry any type in case of the load-bearing structure. And it says that good quality masonry for even RC buildings. Now, you fill the ground floor, which is open. If you fill it with the masonry infill walls, then we have seen that the performance improves a lot. But ultimately, what will happen? These infill walls, they are going to fail because they enhances this lateral stiffness by several times, even when you provide these at the ground floor, open ground floor. So what will happen during the earthquakes? The first thing that is going to fail are the masonry infill walls in the basement. So next thing that happens is the conversion of this fully infilled buildings to open ground story buildings. So we have to be careful when we use these masonry infill walls, even in the ground floor. So what we have to do is to try and prevent the out of plane collapses of these walls, to have sufficient strength to these walls, to have sufficient deformability in these walls. So that is important. We need to prevent the failure of the ground floor columns. If you remember in one of the slides, that Professor Ghosh showed, because of provision of partial height infill walls, the columns failed.
Yes.
So that is a very standard example of short story column effect, short column effect.
Yes.
So we have to avoid these things. So if we can avoid these short column, we can avoid the out of plane collapses of the masonry walls. Then I think it is possible that these masonry walls, particularly in the ground floor, they will save the building from total collapse.
Yes, sir. I think it is addressed. Okay, next question, Mr. Alex Thomas. He was asking about the pushover analysis do any good?
Of course, it will do good if you do properly. The main problem with all this nonlinear analysis is we need a lot of data. A lot of input data is required, which is difficult to find. So the quality of output is, of course, dependent on what kind of input we are providing. So that is why whenever you want to carry out any of these analysis, for example, this pushover analysis, you have to validate first with some tests. So the test results that I showed, most of these test results can be validated, can be used for validation of the pushover analysis results. It is very similar kind of testing that we did. So if you validate them, you tune your model, change the properties of your model such that the results are matching, there is a chance, high probability that your analytical model is correct, the numerical model is correct. But still, there are still possibilities that the model is not entirely correct because you are tuning that model to match the results with the experimental results. So it's very tricky, but no harm in carrying out the pushover analysis because it will give you another tool to compare your results, which you can, they compare the hand calculations, compare simplistic analysis, linear analysis, linear static or linear dynamic analysis results. So there's another tool through which you can actually compare the results.
That's right. I think the question is for Professor Chandan Ghosh sir. Ghosh sir, can you hear me? Are you available? Somebody is asking if relying Rishabh Singh, again, he's asking a very good question. If relying on software simulation is not helping us in designing structurally safe structures, then how can you move forward in safe structure designing, considering the fast pace of infrastructure development in today's time? A very good question indeed. Ghosh sir, you are available with us? Okay, no issue. I can also address.
Yeah, I think some part was already addressed in the previous reply.
Yes. Yeah, software simulation, obviously we have to consider for designing the structures, considering the pace of but we should use it not like a black box. We have to understand the it is my view. I also worked in simulation. So it should not be worked as a black box. We have to understand every module when you are modeling the elements of the structure, and while we are giving load also, you have to understand what should be the loading, what loading we are giving. So that I think that we have to take care of, and obviously we have to see the past experiences while we are designing these kind of structures, as Professor Chandan Ghosh has critically highlighted. Next, an anonymous person has asked, filler wall between columns are to be perfectly joined with the columns, or some gap is to be left. Kaushik sir, you want to address this question?
Yes, I remember Professor Ghosh said in one of the slides that it is, it is one of the solutions that if you leave a gap between the columns and the walls, pillar walls, then the columns will not be damaged. Particularly the short column effect will not be there. But if you do that, there's another possibility of failure of these walls in the out of plane direction. So if you're providing some gap between the column and the infill walls, then you have to be careful in somehow connecting these infill walls to the columns such that they are not falling in the out of plane direction.
Yes, that is also true. Next, Manish Sarji, somebody has asked you again, Mr. Rishabh has asked you a question. I think you can see it. Dear Manish sir, why IS 13311 is used in your sample report for rebound hammer and ultrasonic pulse velocity and not the part of IS 516? I think you are mute, sir. Please unmute. Host, please unmute Rishabh, Mr. Manish Bhartiji.
Yes, sir.
Audible.
Generally, we used to do the audit for the old structures. So whatever during the construction for the quality monitoring for the quality purpose, they have adopted the old codal provisions, not the new code. So that code 516 has been changed in the 2018 recently. So all buildings which were initially in the in the quality, in the good condition or the medium condition, for example, even in the doubt condition. So now the all buildings which were falling the doubtful or the medium, right now they all are in the poor condition. So within in the change of the 1 year, we can't declare that building is from medium to the poor. So in general, it is we should consider the old code, considering which they had constructed the building. We can't check the audit of, as per the upgraded code unless you want to improve the all retrofitting of the structure as per the upgraded code. So there's a two type of the repair. Repair is following the original capacity. You want to enhance or restore for the original capacity, but you want to go for the retrofitting of the structure for the new seismic code, then we generally adopt for the new code. For the generally for audit purpose or quality audit purpose, we should adopt the old code only, because of course you will get the fail.
I hope his question is answered, and he is again pointing out another issue, Rishabh Singh. Considering a scenario where many reinforcement bars are facing corrosion and loss of cross-section due to the same, while some reinforcement bars are facing corrosion only up to surface with no loss of cross-section. So number of such reinforcement bars would be in a G+2 story building. What methodology could be adopted to estimate the quantity the reinforcement require repair?
So in the repair, generally we generally classify the loss of section in three classes. One, the less than 20%, between 20 to 40%, and 40 to more than 40% loss of the section side. So if it is more than 40%, then we generally ignore the strength of the reinforcement. We don't take any consideration of the existing strength of the reinforcement in the analysis. So generally we go for the structure RCC jacketing using the 100% taking the new rebar. When it is a 20 to 40% loss, in that case we generally take the compensation of the loss percentage. And if it is below the 20%, generally we add on the your fiber mesh or the chicken mesh or the welded mesh as per the requirement. Now we are coming generally the 20% loss. It is generally localized. And whenever the hole throughout the crack, throughout corrosion will appear in the structures, it will not appear limited only to 20%. Generally, you see the whole spalling of the concrete. In general, in that case, loss of the reinforcing more than the 40%. Now I'm coming the how will diagnose it is a 20% or 40% or the more than 40%. So on the basis of the half shell potential, we generally take the risk of the corrosion, not the exact the loss of the bar diameter. So generally we assess and do the corrosion mapping of the existing structures, and where there's more than 90% chance of the corrosion, that portion will expose the reinforcement. And by using the your rust remover, there's one chemical, we check by the vernier caliper, we check the diameter. So where if there's more than 90%, so we generally check how much the possible reinforcement section size loss. And below the 95% loss of the risk, corrosion risk given by the half shell potential, we generally don't consider there is any loss in the section size. So these way actually generally we estimate, but thoroughly actually we can't estimate each member at each location. Generally you have to take the interpolate the data, and you have to same cheese you have to also interpolate in your model how much the loss you want to take. If you want to do the conservative, so there will be different method. If you want to take the some risk, you can ignore, and if you want to take the perfect way, then you have to go for the lot of diagnosis. For example, as per the ASTM, they are telling if you have the risk for the bridges, so you go for the whole corrosion mapping, the DAG slab, and then you just concentrate which location there's a more than 95%, and even in the 95%, you have to make the minor grid. Generally, ASTM code recommend you have to check the at the 5 meter by 5 meter grid level, check the corrosion risk. But if it is more than 95% corrosion risk in any area, in that case, you have to go for the at the 300 mm to 300 mm spacing in the both direction. At least you can check the corrosion risk in the main reinforcement as the your transfer direction in the your distribution reinforcement. So this is the system, and totally depends upon the designer how much they want to take the. They want to incorporate their risk loss of the section in the model analysis.
I think you have addressed. Yeah, rightly pointed out. Another question, I think Mr. Ajay Bharti is asking whether jacketing can help to increase the strength of RCC structure. Obviously, or it will help only from external part of structure. I think obviously jacketing is helping.
Jacketing is the perfect way if you want to, if you can do the monolithic something. But in the jacketing, there's a one issue. For example, if there's some corrosion already existing in the concrete, okay. So now you want to add the extra reinforcement in the corroded reinforcement, but still the corrosion in the original concrete, because you can't vacate the whole concrete from the column, because only up to the certain level you can just demolish or chisel out the concrete. So when the new reinforcement will come and old reinforcement existing already in the concrete, so if you are not well protected and if your concrete is not in dry, in that case again chloride content more than threshold value 0.6 kg per cubic meter. If there's in the concrete, they will attack in the new reinforcement also. In that scenario, your rate of corrosion will be double what is expected, because your diameter will get changed, and your thermal your electrothermal, your conductivity of the your current will be the different if your reinforcement density is the different. Okay. So in that case, you have to very particular in terms before the jacketing. At least you should check the chloride content in the existing concrete.
Yes. Thank you, Manishji, for nicely illustrating. Somebody is asking about the can everyone use. Sunistha is asking, can everyone use this Resilometer app?
So right now, actually, we have developed for we are doing for our commercial purpose, and but actually once. Actually, we had also demonstrated to the NDMA, but we actually we couldn't commercialize on the whole perspective all pan India, because different IIT has also developed the own RVS score. Okay, NDMA has the own, FEMA has also, and in the CBRI they have. So unless if I launch my own product, so there's a credibility issue. So which one is the better? Okay, so in the even our app, we have given the different option for the CBRI purpose, or IIT Ravi Sinha sir has developed one. The also Arya sir had developed that RVS score. So we have incorporated all questionnaire their score. So it is depends upon the user. So user can select the which assessment method you want to adopt. On that basis, we can get the for the same building for different RVS report. And it depends upon the you which will give in the more judgmental. So we have not generated on the score table, because we have not done the simulation or the your unit model test in our laboratory. So we don't have on score table. We are using for the score table of other developer we have developed. We are the only the facilitator through our app. Okay. So
No, that is
unless we
fine.
get
That
the
is
assurance from other, we can't launch for the commercial purpose for general public.
Yeah, Monish sir, that is fine. We understood. But the question is that, and everyone can use this app? Is it
Yes,
available?
I can give, and on the basis of the only for the 10 survey, it is a free. After 10 survey, you have to pay some for the cloud charges or something.
Okay. So thank you for a nice discussion. And I think we have answered many of the questions. However, if some questions are left, I will request our learned audience to directly contact to the panelists, today's panelists. I think they'll be obviously reachable through email. So there is no problem in today's world. Now the time has come to sum up the discussion for today's very important topic on earthquake, a mega disaster event, and the learnings we learned from the various earthquakes decade after decades, and the challenges, key engineering challenges, and the mitigation. So firstly, Professor Kaushik has illustrated in a very methodical way how the basically the strength assessment of different type of structure experimentally can be done, and it has been already conducted in IIT Guwahati with the state-of-the-art facility of this. I mean, the several actuators are there, as well as the shake table test on full-scale models that obviously will help to understand the behavior of different cluster of structures which is being constructed in particularly in our country, and obviously especially Northeast India. So from the point of view of recent Turkey earthquake, which has sensitized every people from every part of the world, such a devastating earthquake, even after we have developed a number of codal provisions, and that is quite advanced. Even after that, we have experienced recently the Turkey earthquake, which has sensitized every people. So that is the basically background of today's program. And obviously, we will be organizing such webinars in current days also. So different learnings we have got. Obviously, we have got different learnings, and those learnings are being post-analyzed and being documented, and which may help the design codes of every country, I believe. So Kaushik sir has nicely presented his experimental works, which will be definitely highlight or enlight to develop the IS course in our country and more strengthened the earthquake resistant design part also. Professor Ghosh has given critically analyzed the failures of the past learnings. From the past learnings, he has critically analyzed and given some of the key areas what attention to be made by the researchers as well as the engineers as well as the policymakers. So these issues need to be we have to think of not in the conventional manner, rather from the lessons learned from various failures. So thanks, sir. Thank you for your nice motivating lecture and guiding us for driving a new direction, not only limiting our scope. Obviously, our last speaker, Monish Bhartiji, has given a new direction, I mean, new area, that is the structural audit, which is a very pertinent issue at this hour. In our country, many parts, including our Tripura, northeastern states, we have several archaeological monument structures are there. And recently it is going on, such rigorous structural audits are going on for strengthening, for retrofitting of these structures. This is a key area which we have to understand very nicely. So comprising all sort of discussion today held, we have obviously developed we have refreshed our ideas, we have tried to understand the basic state of the art and what is the direction of future engineers, future direction to basically resist or mitigate the disaster, which may obviously we cannot stop the natural disaster. These forces will obviously natural, and it will definitely come according to their pace. So we have to be prepared, and we have to be very structured. Our preparedness level shall need to be enhanced with the understanding level, with enhancing the level of understanding. So I believe such seminars, such webinars are very useful for the designers, engineers, students, and different stakeholders who are involved in this particular mitigation strategy. So with this small note, I would like to conclude my theme lecture on this particular issue. Sir, over to, I think, our Honorary Secretary, Dr. Minal Kanti Dev, sir. Thank you.
Thank you, Dr. Rajiv. I think I am audible.
Yes, you are audible, sir.
Okay, thank you. Thank you very much. So it was nice, long discussion today. We have a technical webinar. So it is a time to propose a vote of thanks, customary. So distinguished guest, ladies and gentlemen, a very good evening to one and all present this particular evening technical webinar. It is my privilege actually to have been asked to propose a vote of thanks in this IEI technical webinar on earthquake, recent topic, earthquake, a decades-long mega-disastrous event, lesson learned, key engineering challenges, and mitigation, which is organized by Institution of Engineers, India, Tripura State Center, under the aegis of Civil Engineering Division Board, IEI, Tripura State Center. So I'd like to thank Dr. Rajiv Shah, Associate Professor and Head, Department of Civil Engineering, NIT Agartala, who had accepted our invitation and introduced the panelists today to the audience as a moderator. And on behalf of Institution of Engineers Tripura State Center, I'd like to convey our sincere gratitude. I must appreciate and thank to Professor S.K. Kaushik, Professor Department of Civil Engineering and Center for Disaster Management and Research, IIT Guwahati, for inspiring and encouraging actually the trends is talked about the special topic in this particular issue. Thank you, sir. I also like to thank Professor Chandan Ghosh, Professor in NIT, National Institute of Disaster Management, for sharing with us his findings and opinion at recent topic, recent trends. We're really grateful to sir. Further, so I'm grateful to last speaker, Mr. Monish Bharti, who is CEO, Contracts Construction Solution Private Limited, for demonstrating his views on particular theme and potential various solutions and software tools. I mean, the demo he has shown like app, which is very much useful for survey purpose. I also extend my thanks to our very active chairman, Dr. Shubhadeep Bhattacharya, FIE, the Institution of Engineers Tripura Research Center, for his enormous cooperation in this organization on this to conduct this kind of webinar. I also like to thank all the distinguished delegates, respected past chairmen, respected past honorary secretaries, respected council members, senior corporate members of IEI, who have given us to valuable time for today. They have spent our 3 hours time in particular seminar. I'd like to thank our various honorary official bearers. Those are silent workers behind the scene who have ensured the success of today's webinar. I also offer sincere thanks to various industries, firms, other organizations who have helped us directly, indirectly about the lecture program in this particular webinar. So, ladies and gentlemen, an event like this cannot happen overnight. The wheels start rolling almost few months ago. So it requires planning and bird's eye for details. We have been fortunate enough to be backed by a team of very motivated and dedicated civil engineering division members of the IEI Tripura Research Center. So, and special thanks to Mr. Sudeep Chakraborty, Deputy Director Technical of his team of IEI headquarters, for their continuous support. And this is actually a approved program, a continuous professional development program of IEI, which is supported by IEI headquarters. So once again, I want to state here, we are most grateful to all the speakers today's webinar. So also the audience from various institutions for attending today's webinar. In such a large number, it was like almost 100 attendees previously. Right now, almost still we have a 60 plus. Thank you very much. Good night. So we look forward.
Thank you, Jai Hind, sir. Thank you. Thank you, Professor Kaushik, sir.
Thank you. Thank you all.
Thank you.
Thank you.
Thank you. Thank you, sir. Thank you.
Thank you, Monishji.
Thank you. Good time.
Thank you,
Monishji.
sir.
Thank you.
Right.
Thank you to all
Thank
the
you, everybody.
panelists. Thank you, sir.